Okay, let's do some more shell method ones. So this is shell method. And I have my function y equals x minus x squared. I'm bounded by y equals 0 and the line x equals 2. So this isn't around the y-axis. We're not revolving it around the y-axis, but it's kind of like it, right? We're just moving the y-axis out to x equals 2. So we need to be able to draw this to figure out how to come up with our radius. And so let's see what this looks like. So if I just simply draw my function, my y equals x minus x squared, so that's y equals x minus x squared, then I know I'm, of course, starting at 0, and then if I don't know why I put a 2, I'm in a 1, back. If I plug in 1 for x, 1 minus 1 squared, and that I'm back down at 0. So what's happening here is I want to revolve this around this line x equals 2. So to see this, typically what you want to do then is to continue out this way. And so let's say I go from 3 to 4 and I draw this same function. Pretend it kind of looks the same. And so with this shell method, this is what I'm doing because I'm revolving it around this x equals 2. Then I'm taking my shell, my piece here, and that's what I'm revolving. So that's why we end up with something that looks like this. Okay, again, don't laugh at my drawing. But this is kind of key because we need to figure out what this radius is. So what I could do is I could say, well, from 0 out to some value, let's just call that x. I don't know what it is, we're just going to call it x. Well, then now I know what this is in terms of x would be 2 minus x. Where'd the 2 come from? Right there. And so I have my formula that I can use, my volume formula for the shell method, which says if I'm revolving, in this case, around a line, x equals some value, I'm looking at my function of my x values from 0 to 1, that becomes my limit of integration, 2 pi, just said that the radius is 2 minus x, and then of course my height is going to be my function. So x minus x squared dx. And now all I got to do is my antiderivatives. So I'm going to go ahead and combine some stuff here first. I don't know why I got 3 lines there. 2 pi, still have my limits of integration. 2 times x, 2x. 2 times minus x squared, minus 2x squared. Negative x times x, minus x squared. And then negative and a negative, a positive, x cubed. And I can go ahead and combine those two, and then I'll be ready to find my antiderivative. So 2x minus 3x squared plus x cubed dx. So from here, I do my antiderivative, which is where I add 1 to the exponent. So of course 2x to the first power becomes 2x squared over 2, so the 2's cancel, meaning just x squared. Minus 3x squared becomes 3x cubed over 3, so the 3's cancel. How lovely. And then finally the last one becomes x to the 4th over 4, nothing there to cancel. And I'm evaluating from 0 to 1. So I plug everything in. I get 2 pi 1 squared minus 1 cubed plus 1 to the 4th over 4, which is 2 pi 1 minus 1, 0, 1 over 4. which is 2 pi over 4 or pi over 2.